Alright. I gave you guys 3 questions the other day on Tuesday to work on in the class here. So we're gonna go over the answers for them. I need to open up that video 1 second. I thought I had it open. Let me see.
Hey, I'm William. Today we're going to test the thermostat on electric GE.
This is the video, but let's go over here. Okay, a lot of people didn't do what I wrote down, and I want to explain first what I wanted you to do. So I put this YouTube video of a guy that's just checking a thermostat in a dryer. This is a dryer thermostat right here, okay? And it's got 2 terminals on it. Oops. It's got 2 terminals on it. Most thermostats are closed, and when they get a certain temperature, they open, but some thermostats are opposite. They're open, and when they get a certain temperature, they close. But the video just showed you how to check it. And the video was from I'll figure out what the website was so I can give them credit, but that was like they sold parts. So all they did was tell you, okay, this is how you check the part, if the part's good or bad. But it's not so much troubleshooting. I was going to use a video to ask you questions about the thermostat. Turn the fan off, too loud. Okay, so I was going to get a video on thermostats and ask you guys about thermostats. And then when I was watching this video, I said, wow, you know, something really like caught my eye, and I wanted to see how many of you actually saw that. So let's go take a look at that video for 1 second now. And I'm going to fast forward just a little bit here. So the website is Appliance Parts Pros. I'll give them credit because I'm going to use their video for this.
AppliancePartsPros.com.
But
first, we'll need to get our tools together. Today,
let's
we'll
just
need
watch this for a
voltmeter
second.
and a Phillips screwdriver. And please remember that safety comes first. Always disconnect your dryer by unplugging it or switching the breaker off. Now let's get started. To get it to the inlet thermostat, we're going to use our Phillips screwdriver to remove the 2 screws at the top of the front panel, just behind the door. Now we're going to lift the top panel up just a bit so we can clear the console legs and pull it forward. We're going to remove the Phillips screws that are found at each back corner of the front panel. Once we've done that, we can lift the front panel up, rotate it to the side, and disconnect the door switch wires.
okay, before we go any further, do you guys see anything right now? This isn't the key part that I want you to see, but again, looking at the dryer, you know, when you guys are working on a machine, you're taking them apart for service, be observant of everything. Look, see what you see, because sometimes what's wrong with the machine is right there in your face. You just don't know what you're looking for. So I mean, like, look here.
Worse.
Lint buildup.
That's a lot of lint buildup, right? Okay, but it's not that much, you
You
know.
can
The
see it
guy,
on the edges where the blower wheel would sit as well.
so you see a lot of lint build up here, right? Okay, so let's keep going. So he's
Then we
disconnecting
can
the
set the
door
front panel to the
switch.
side. With that moved out of the way, we're going to reach
More
under
buildup.
our drum.
Look at all this lint.
Yeah.
Okay, so look at down here. Now, all dryers gonna have lint in them. You're never gonna find a dryer that's perfectly clean after 10, 20 years of running. And that dryer is an older dryer. That's not a more current GE dryer. But immediately when you see this lint, what do you think?
You clean it?
Yes, you would clean it, but first we're going to go and diagnose the problem. We're going to estimate the repair to the customer, and if they want to repair it, we say, okay, this is how much it costs to fix. Let's just say a no heating problem. That's why we're talking about a thermostat, for example. But to clean it, you may just brush it out, but you might say, hey, listen, this thing's real dirty. You know, for an extra $30, I'll clean it up. You take it all apart, you'll oil and lubricate the rollers, you're gonna check the belt. And those are kind of things that you would normally do on any machine you're working on. Even though a customer calls you out and says, I got a dryer not heating, you don't just go there for a dryer not heating. You go there and figure out what that problem is, but you're gonna look and check everything else, because there might be a belt that's frayed and on its last leg that the belt's gonna break. So you want to be able to tell the customer, hey, I see this and I see that. and that if you wanna repair it, this is what I recommend you do, okay? So the thing is that if you don't do that, I've had a lot of technicians go and repair the heating elements back. They put a new heating element in, and they leave. And the belt was old, and a week after you fix it, the belt broke. So what do you think? If I went to your house and fixed your dryer and put a new heating element in, and a week later the belt broke, what would you think?
Why didn't
Yeah,
you
you
fix
know what
it?
you
Not why did I fix it,
Why didn't you?
that
Why
maybe
didn't
I
you
was
fix it?
responsible for the reason why the belt broke. And then how do you tell a customer a week later, well, ma'am, that belt was going bad, I noticed it, but I didn't say nothing.
Why you didn't say that?
Now, you're gonna sell a job, sell the parts or whatever. Remember, we pay wholesale on parts, you charge retail, so you're making money on every part you sell. I'm not telling you to sell them parts they don't need, but when you're working on a machine, be observant.
Yeah.
Because you don't want a customer to be able to say, oh, well, it was working fine just before you got here. Now, what's a coincidence a belt broke a week after you left? It was a coincidence, it was an old belt.
Yeah.
The dryer in the picture is almost 20 years old, okay? But you don't say nothing. Now the customer is going to say, well, how do I know, you didn't do something wrong that caused it to break? And normally, if you're gonna do a job, you have to warranty the job.
Yeah.
My company, we give 90-day guarantee. So if we go and we install a part, we'll cover that for 90 days. But what if a technician did make a mistake and didn't put something together right and it came apart? Well, we gotta go back and fix it.
Didn't fix it.
But if it's a belt that's worn and it breaks, how do you charge a customer for that when you should have brought it to their attention, okay? So always, when you fix something, don't just fix the one thing and run out the door. Check everything while you got the machine apart, okay? So yeah, there's excessive lint everywhere, but why is there that much lint, do you think, inside the machine?
Like you said, it's been running 20 years.
It's leaking.
It says the duct, you gotta check the duct because it might be backed up.
If the ducts are backed up, see what happens is dryers work off of a negative airflow. Do you know what that means when I say a negative airflow? I'm gonna go to this other page here real quick. So, here you got a dryer, and I'm gonna draw it like it was open, okay? So you got a drum here, and then you got a fan down here. And the front of the dryer, the door has a little filter housing that goes in, and this runs out the back of the machine, the vent, okay? Now, negative airflow means that instead of the fan blowing into the drum, the fan is sucking the air out of the drum. Okay, so the heating element is back here, and he's gonna show that to you in a minute. And so the fan is pulling the air in the back of the machine over the element into the drum, and from the fan out the dryer. Okay, so if the vent is blocked, this fan will blow everywhere, and that lint's gonna go inside the machine. Okay, so that image alone is just saying, hey, there's something wrong with the airflow, right? But even those two things that I pointed out to you wasn't even what I saw that I wanted you guys to see. Let's go back to that video for a second. And let's finish playing this video.
And we're gonna disconnect the belt from the belt pulley.
One
Once that
hand,
is
guys.
disconnected, we're gonna go ahead, lift up on the belt, and use it to assist in pulling the drum forward and out. Now we can set that to the side as well. The inlet thermostat is next to the safety thermostat, second from the left, and we're also gonna test this for continuity. First, remove the leftmost wire and the outer center wire. Then place one probe on each.
Oops, hold on a second. Hi. Look at that picture. Anybody see anything in this picture?
He's trying to pull up the. He has a screwdriver in his hand.
No, that is the
The
meter
tester.
leads to test that thermostat.
Okay.
But what do you see in this picture?
Dust,
Where do you see the dust?
what's on the back of the dryer?
Where's the
From
dust? I
there, by
don't
the-
see
by the-
dust.
By the springs.
That's the heating element.
That's the
Yeah, but what's on the black spot? on the,
Lint, buildup.
This?
yeah,
Buildup.
That's excessive heat.
excessive heat. Oh,
So it's burning.
It's lint that burned on the housing. But there's more to it, look at the element. Okay, I want you guys, look at this element sagging here,
yes.
okay? I'm gonna show you what a new GE element looks like.
Oh, okay. I need to replace.
Well, hold on.
Mm.
It'll take a little bit at a time. Now I got the new style and the old style, so let's look at this element right here. $150. I got a good video on how to restring that for 15, 20 bucks, and you see the retail price is $150. So you watch my video on how to install the wire element inside, and then you clean it up, and then you put silver barbecue paint or stainless barbecue paint,
Stainless.
because it'll withstand the heat. And
Stainless
so you
barbecue
take the
paint.
element out, you clean it, you wash it, you sand it a little bit, you put the paint on it, you put the $20 element. Don't charge the customer $75, you charge them $100 and just say, well, this is a remanufactured element. The retail is $150. If you want, I'll get you a brand new one, but I got this one on the truck for $100. And you warranty it for 90 days just like you would a brand new part.
Is that an aerial view of the?
No, it's
Part.
Well, the elements, normally it's horizontal, but yeah, it's like looking
Yeah.
down on it.
Yeah.
It's got two elements inside, but notice how straight the element is.
The other
It's
two
not
sa-
sagging like the one in the video, right?
Mm.
Again, that sagging is evidence
course.
of no airflow. This dryer has a problem with air circulation, and when the element gets hot, it
This
sags.
side.
I don't know if you ever seen a toaster when you put bread in there and it's got the little, toaster element lines, they sag, and then when you turn off, they
Get back.
tighten back up. But this one ain't gonna tighten up anymore. It'll work. Problem is though, is that
You won't.
it's gonna break if it got that bad. So the evidence was airflow. That was the first thing I want you to observe. But then the next thing, and you guys didn't have well, you did have a diagram, I think, in the book. But a diagram. If this element was getting too hot, what components do you think would fail that cause that thing to fail? The element would probably be bad. Remember, I stated in the question, if you went into someone's house and dryer's not heating and you check the thermostat and the thermostat's good, all of a sudden you saw that element burnt and sagging, you say, oh wow, there's an airflow problem here. What components in this machine would most likely cause a no heat when you have poor airflow? Now, one thing would be the element. I would think the element could be at fault, but I would also go to this right here. One of these two components, but this controls the motor, but I would go to the safeties, because if it was overheating, the safety might have failed. And changing the safety doesn't mean you fix the problem. If the machine was overheating, and this is like a fuse instead of a thermostat, and it goes bad, it doesn't reset. You put it in, the dryer's gonna heat. Did you fix the dryer?
No.
Why?
The issue persists.
You what?
The issue persists.
Yeah, you put a thermal fuse in or a fuse in there, you're gonna get the heating element to work, but if the customer's having an airflow problem, the fuse is gonna go bad again. So the point is like when you're going to fix something, sometimes just changing a part doesn't necessarily mean you fix the problem. This part failed because something else was wrong inside the machine, and you have to go further to figure out why did it fail. Whirlpool, and I have like 3 or 4 videos on Whirlpool dryers, so I'm not gonna do that now. But a Whirlpool has a fuse in series with their motor that's in the housing where the airflow goes out. And there's a thermostat in that housing that's 140, 160 degrees. But right next to it is a thermal device. Now the Whirlpool one's just a little white one, but right next to it's a thermal device, and if it goes bad, you have to replace it. It doesn't reset. Well, if I have a thermostat here at 140, and I have this at 196 degrees on the Whirlpool, that's how much hot it is. If this is bad,
It's gonna
is the
burn.
thermostat the problem?
No.
Could be, because it shuts off at 140.
Oh,
This went bad at 196.
oh, okay.
What caused it to get that hot? You see what I'm saying? Like, you need to not just see that this part's bad, you need to find out what caused that part to go bad,
Okay.
all right? So, these are the two main things I would look for when I saw it. Does it mean that all the thermostats in there are good or whatever? Not necessarily, okay? So, the answer to that question, if we look at it here, in the video, thermostat test good, based on the visual clue shows what specific components might you choose to test next. It may be the element, it may be a thermal fuse. It could be a timer, it could be other thermostats, but by visually seeing that overheating, I'm gonna think I have a problem with heat, and maybe even one of my safety devices went. Okay? So that was question number one. Anybody have any questions about number one? No? Okay, let's look at number two. GE dryers have two thermostats, one on the inlet and one on the outlet. So remember I showed you in my drawing, in here, you have, let me remove some of this stuff here. Oops. I gotta go back further. So I told you, this is the blower housing here. So on the blower housing, there's a thermostat right there. And that thermostat is sensing the air leaving the dryer. So at 140 or 160 degrees, which is what this thermostat's set at, it shuts the element off. Okay? That is the outlet leaving the dryer. Remember I told you the heat element's back here, right? And that's where he's testing. There's another thermostat there on the heating element. That's the inlet, the air coming in the drum. So air's coming in here, going through the drum and then going out. So we cycle it on the outlet. The inlet is usually there for safety, but this one has two thermostats. Here and here on the outlet and the inlet. So this one's on the heating element and the other one's on the fan going out the dryer. So my question was, why the two thermostats? Usually,
One control the.
this is a high limit and it only acts as a safety. But GE did something different and they added this little piece on the bottom of the thermostat. Now this thermostat isn't that one because it only has two wire terminals on it. That one has four, it has two more smaller ones. Does anybody know what the two smaller ones are? That's this piece on the bottom. So you got a thermostat and you got a little heating element inside there. If you look at this symbol right here, isn't it the same as the heating element there? Right, isn't it the same drawing?
Yeah.
So inside the thermostat, there's a heater. And I told you this thermostat goes at 140, 160 degrees. Well, inside of here is a little tiny heater. It's not to heat the air, it's to trick the thermostat. So let's just say 160 degrees is this thermostat. So as the air is flowing by it at 160, it opens up, turns the heater off. Now the heater's off, the temperature's going down. It closes again and the heater comes back on. But what if I want a different temperature? You say, well, what do you want a different temperature for? Well, you got jeans and towels that are gonna take high heat.
High heat.
But you have women's clothing like lingerie or other things, silk clothing.
Low.
You can't run on high heat, you'll damage the clothing.
Yeah, low. Oh,
Now,
yeah.
back in the day, they had three of these, 160, 140, and 120. And there's a switch, you put it on delicate, it would send power through the 120 thermostat to the heater and it would cycle on and off. Well, Whirlpool, a long time ago, changed that. They took the 3 thermostats and said, well, we can use one, 160. Put a little heater inside. If I turn the heater on, I can trick the thermostat and think the
Control.
air outside is 160 when it's 120.
Controls it.
So we can get multiple temperatures from a single thermostat. But why the 2 thermostats?
One control the heat and monitor the desired drying temperature.
They both control the heat. They
Yeah.
both control the heat, but they control the heat for different things.
Yeah.
If I do not turn this on or this on, these thermostats are gonna cycle to whatever temperature they're set at. Now let me see this one. This one you can't really see it too well. But they print the numbers on the thermostats at the temperature the thermostat cycles, okay? So what happens is if you look at this one, power goes from here to this heater, but it goes through this thermostat for the other heater. And if I don't turn on these little heaters inside, both elements are on, I'm gonna get 160 degrees. Estimate. Could be 140, 150, 160, but high heat, okay?
The second one has a
But
high
if I
heat.
turn this on, I'm gonna cause that to short cycle and it's gonna turn off one of the 2 heaters to give me less heat. But when is this turned on? Well, if I look, there's a timer switch right here that controls that, right? And in order to find the answer, we need to go to the book here. Let me see if I don't have it here. Let me see something. I don't know which one. Let me see which one of these 2 is. No, I don't
Second
know.
one, high limit thermostat.
I just had it open a minute ago. Let me see if it's in this one here. Okay, I don't have that in front of me, but if you look at the diagram on the machine, and I don't have it here, I should have had it before I started lecturing. There's something called a timer chart that tells you if you're in this cycle, this is what is on. I'm just gonna tell you right now, on this thermostat here,
Second one,
that switch is only closed in the low temperature settings, the delicate and the permanent press. So in other words, it's gonna cycle that heater off on a lower temperature to give us less heat. But if this one opens, which heater does it control?
the high,
But which heater, the inner or the outer?
Inner,
If this one goes off.
the inner quote.
Well, let's go back here where I can draw it. If this one is open, power can't get through there. Where does the power go? Here and here. So when that thermostat opens, both heaters are off. This one opens, only the outer goes off. But if I don't turn on these bias heaters, I'm gonna get the highest heat possible. If I turn on the bias heater, or I turn on both of them, they're both gonna short cycle and give me lower heat. So if I have this on and this on, well, what controls this one? Well, if we go here,
this one.
guess what? That gets power when? When this timer switch closes, because power comes in and goes through that timer switch here to control that one. So that'll be like a permanent press cycle. I'm sorry, a delicate cycle. So for delicate, I'm gonna close both of these and have both of them run at a lower temp.
Low temperature.
But if I'm permanent press, I'm only going to close this one,
Get the second one.
but not this one. So then I get a medium heat. And if I want high heat,
The second one.
this is open and this is open. Because neither one of them are cycling on low temperature. So that's why we have 2 thermostats. Where they are ensures that you get the most accurate temperature, both inlet and outlet. Because when air comes in from the element, even though thermostat's set to 160, The drum temperature is gonna be hotter, 180, 190. Okay? But that thermostat coming in is going to sense that temperature. Once the air comes in the drum at say 180, the moisture in the clothes is gonna start to evaporate and lower the drum temperature before it goes out, so the thermostat can control it. So even though it's at 160, the moisture in the clothes is what's causing it to lower that temperature down from 180, 190 coming in. You guys got any questions on that, the two thermostats? Yes.
There's like a diagram that shows you, like, according to which cycle you wanna choose.
There's a
which one-
chart that tells you all of these timer switches,
Yeah,
and there's another timer switch over here, what cycle they're closed in. Okay?
yeah.
You did the diagrams and schematics package? Didn't you answer the questions on the dishwasher?
Is this, is similar to the washer?
It had
machine?
no, it had a dishwasher diagram with questions about,
Yeah,
you did that one?
yeah.
That one is a timer chart for the dishwasher timer.
So the dryer one would be similar to that?
They're pretty much identical. A timer chart is a timer chart.
Yeah,
So in a timer, it's a dial like a clock, but it has multiple switches in there that open and close as it rotates. And they turn the heater on, turn the heater off,
okay,
turn the motor on, turn the motor off.
yeah,
And it tells you how much time the timer's gonna be in that cycle. So it gives you time of the cycle, and it tells you what switches are closed in this cycle and what switches are closed in that cycle. I'll show you it after the lecture, but I should have had that up before I started. I apologize.
Yeah.
Any other questions?
No, I
Okay, let's take a look at the third one. Okay, explain how the power resistor and timer motor are used together in the dryer circuit. So let's take a look at this circuit. And you were supposed to use this diagram that I had here. I took it out of the book. And so here is timer motor and here's your resistor. Okay, there's two things here. Power comes in and goes through the timer. And watch how we go. It goes here, here, and here to neutral. So that means that timer motor is getting 120 volts right now. And that's normal for a timer to get 120 volts.
Mhm.
Okay? But what happens if, let me erase some of this. What happens if I don't close that timer switch? Well, if I don't close that timer switch, I can't go that way. I have to find another way for power. So if we go down through this resistor, it goes through this heating element to line 2. So the purpose of that resistor, now that we're on line 2 here, and line 1 here, now I put 240 to my motor. You cannot take a motor that's 120 and all of a sudden put 240 to it.
You burn it?
You're gonna burn the motor right out. So what they did is they put it in series. You guys all know when you put the two light bulbs on in series, they're not as bright because they're sharing the voltage. So the purpose of this power resistor is to drop the voltage down to the timer motor in this cycle. But what's the advantage of it? Why? I mean, you know what? I don't care whether I got the timer running in the first cycle or in this cycle. Guess what? The temperature of the dryer is still gonna be 140 or 160. And towels, no matter what, are always gonna take
More time.
40 minutes, an hour to dry.
Yeah, they're heavy.
So what is the advantage of changing how long the timer runs or how fast the timer runs?
Unless you want more time to dry the clothes.
Yeah, but I could have done that in time dry. Time dry is I put it to 40 minutes, I walk away, I come back 40 minutes later and the dryer's done.
Yeah.
This is called auto dry. But it doesn't make it any hotter, it doesn't make the drum run any faster, so what's the advantage of that cycle?
It controls it.
It
It
what?
controls the sequence of the cycle.
But where's the advantage of controlling the timer? In other words, it's not gonna make it any hotter. It's not gonna make it dry the towels any faster or slower.
So 120 will be the best voltage?
Preserving it?
Let me ask you guys a question. You ever gone to a place like Best Buy or something and you wanted to buy a stereo for your house?
Or TV?
Okay, a TV. And you got a TV, it has two buttons, on and off, and volume up and down.
Yeah.
Now, right next to it is the same brand TV, but it has 30 buttons. Surround sound, channel change, on off, volume, got a YouTube button on there, it's got an Amazon button on there, shortcuts. You could talk to the remote and say, go to channel 10 and it goes to channel 10.
Yeah. CNN.
So which TV would you buy?
The one with the 30 buttons.
Okay, but when you're sitting down watching TV, the two TVs look the same.
The same,
You're watching the
that's
same show, right?
Yeah.
Well, the same thing here. By running this here, the manufacturer can put more than one cycle on the dryer. So instead of having one or two buttons, now we can have other things on. It's the same dryer, same drum, same motor, same heater. It just, it's human nature. We want all the buttons and bells and whistles. Okay, but there is a difference in cycle. You say, yeah, well, that's false advertising then, because you're doing the same thing. Yes and no. So what happens in time dry is you run the clothes to dry, and you put it to 40 minutes. The machine will shut off 40 minutes whether the clothes are done drying or not. You put it for 30 minutes. It'll shut off in 30 minutes. So with this particular machine here, how does auto dry make any difference? Well, if you look, the timer motor has to go through this thermostat. So what happens is while it's heating, that thermostat's closed, but then what happens when it gets hot? What happens to that thermostat?
Controls the heat.
Yeah, but what happens to that thermostat? Thermostat's gonna open. And when that switch opens,
Starts getting heat.
the heater's not gonna work, but what's not gonna work either? The timer.
The time.
So, how does that change anything in the machine? Go back to what I said about wet clothes. What did I say about if the clothes are wet, what does the wet clothes do?
It makes the
mustard,
temperature
the
go
mustard.
down.
Makes the temperature go down. So I need 160 degrees to dry the clothes, right? So if I'm gonna press start and the dryer's gonna run, when the clothes are wet, it's gonna take longer
Too dry.
to get to the temperature, but as the clothes get dry, it's gonna cycle faster. So what happens is, whenever the thermostat's open, the timer stops. And the moisture in the clothes are going to change the temperature and everything. So this cycling of that thermostat is going to say, timer run, timer stop. Now, I have to look at this closer because in Whirlpool, when the heater's on, the timer's off. When the heater's off, the timer's on. In this case, when the heater's on, the timer's on. When this is off, the timer's off. So what it does is, it takes a certain amount of time to get to temperature, and then the timer stops. So you put it on auto dry, and the auto dry cycle, let me see, hold on one second. Let me just get an image here and show you guys something. So, let's see if it. So if you see here, this is time dry. Let's see if I get close. This is time dry. I put it there, 60 minutes. It's going to shut off at 60 minutes. But if you look here in this auto dry, there's no time there. And I could put it on the same less dry or the same more dry button, but I cannot say, oh, it's going to be shut off in 30 minutes. It's going to be shut off in 40 minutes. Depending on the clothes that are inside and the amount of clothes, the timer could run longer or shorter based on the moisture level of the clothes.
Okay.
So in here, you may use the same, like that little feather or whatever that is, that same setting, but it's not going to shut off at the same time.
No.
So they are offering a difference in cycles, aren't they?
Yeah.
But it's not gonna change how long it takes for your clothes to dry.
No.
All it is how long the machine's
Depends.
gonna be before it shuts off. Either way, it's possible that the machine can run longer than it needs to.
Yeah. All depends the closure.
Now you got other manufacturers that have sensors in the drum, two metal bands, and when the clothes hit it, the moisture in the clothes conduct a small low voltage current, and the timer says, hey, the clothes are still wet. Let's stop for a second and wait. And every time the wet clothes hit that sensor, they cause the timer to stop advancing. Oh, that's a great idea, isn't it? Let's just take a look at that for a second. Then we'll get back to the question here. Oops. So if you look here, you see these metal bands, they're all in a filter housing.
Those are sensors.
Some manufacturers have them in the back where the drum is, but every time the wet clothes hit that, the board says, hey, stop running, because the clothes are wet. We need to run a little longer. Okay, where is that? In the front of the dryer or in the back of the dryer? Where are these filters located?
In front.
In the front,
That's where the door is. So you open up the door and you reach in and pull the filter out. It's right there.
mhm.
So you guys, when we're done, I want you to just go look at the dryers and see if you can find some of them on the manufacturer. So that works good, huh? What if the installer took the front of the machine and raised the front of the machine up just quarter of an inch, half an inch? So now the dryer's leaning back, right?
It won't touch you.
The clothes will never hit the sensor.
Yeah.
No.
And the customer complained that the machine shut off before the clothes were dry.
Right. Mhm.
Because the sensor couldn't tell there was moisture. It's not the moisture in the air, it's the actual wet clothes. As a matter of fact, when you do the dryers, I used to have guys wet a rag and touch a rag with an ohm meter, and then touch a dry rag, and you could see on a dry rag you don't get a reading, on an ohm meter you get a reading.
Mhm.
Because it'll conduct electricity through the moisture. Okay? Is that a good thing? Does that work great? Or what do you think? Like, let's just say the dryer was installed level. Do you think?
Yeah,
there
it's a
could-
good thing.
Do you think there could be
Installed.
any disadvantages, any problems?
I think
Could it
it's
be
better.
could it be damaged in the front?
Not so much damage.
It's better, no?
Well, like if I said you're gonna buy this, what are the pros and cons? What are the pros and cons of this moisture sensor? Well, one of the cons is if they have the front of the machine up too high,
You
the
only
clothes
have-
will never sense it.
Yeah.
you need to
But what
fix
if,
it right.
what if I'm washing t-shirts, jeans, and towels together in one load? Is a towel and a t-shirt gonna take the same amount of time to
No,
dry?
they will not take this amount.
So if they're tumbling and the towel's in the back and the t-shirt's in the front,
You gotta keep going.
You might have to put it separate.
no, it'll sense the t-shirt's dry and shut off before the towel does, or
Yeah,
vice
yeah,
versa.
yeah, vice versa.
Okay? So there are advantages to it. What if a customer only puts 3 items in the dryer? The dryness sensor's not gonna function properly.
it's
You
not
need to have a
enough to
full
touch.
load. So you may have people call you out and say, hey, I put it on the auto dry, and every time I use it, the clothes are wet. If a customer called me and told me that happened, the first thing I'd do is say, ma'am, I'm gonna be out to your house this afternoon, I'll call you an hour before going. Do me a favor. Throw some wet clothes in the dryer so when I get there, I can see it. First thing I'm gonna look for is the load that the customer put in there. And I'm gonna tell them, I want a full load. Don't just put 2 towels in it. I wanna see a full load. I'm not telling them what I'm looking for,
No,
okay? But when I get to the house, before I touch the machine, I tell them what I'm looking for. And the reason why I don't tell them beforehand is because sometimes customers, like, they just want you to give them a new machine. We had a customer that had a cooktop, and he did something to the thing, and he wanted a new top. These tops are expensive, and they're covered under contractor warranty, but it had like a slight little like scratches or mars on it, like they didn't clean it properly, so it just looked ugly, but it wasn't broken. So our tech went to there and told the customer, hey, you know, it's not cosmetic. We can't change the top because you don't like the way it looks. You just didn't clean it properly. You know, if it was broken, we changed the top. The guy says, okay, go outside for a minute. What do you think he did? Took a hammer and smashed it. The guys walked in and said, well, you smashed it. You deliberately broke it. I'm not changing the top. Customer was mad. But I mean, what he did was,
Purposely broke it, yeah.
I mean, your car, your paint's fading, you call the insurance company and say, it's not my problem, so what do? You bump into another car, now you get the car painted. And the insurance company pays for it.
Yeah.
But that's what customers are doing. So the same thing like customer complains about an ice maker not making enough ice. If I can't see anything wrong with it, I tell them, look, I'm gonna take all the ice out. I need to come back tomorrow and see how much ice is produced in a 24-hour period, don't touch it. And I know it takes 2.5 hours approximately to drop a batch of ice. It makes 8 cubes, and I figure, okay, in a 24-hour period, let's say 2.5 hours is gonna be what, like 10 times? Maybe 9? 9 times 8 is 72. So I'm looking for 70 ice cubes. I'm not gonna tell them that. What are they gonna do? They're gonna take some cubes out and hide them. Okay, but like with things like this,
Pros and cons.
yes, but you tell the customer, put a full load in there. Because I wanna see what you're doing. So you could tell them, well, look, ma'am, you put a full load in here, you didn't do anything wrong, but you have towels with t-shirts, and they don't take the same amount of time to
No,
dry.
they take this amount of time.
Or
No, it's
this
not.
machine's not installed level, so the sensor that senses it cannot sense it. Have you guys ever used those little bounce fabric sheets? Have you ever felt them?
Yeah, they're
They're like,
inside the clothes.
yeah, but they're like oil.
Yeah.
They're like oily.
Yeah, they're oily,
They rub up against there and the oil gets on there, and oil and water don't mix. So the oil prevents the wet
Sense.
clothes from touching,
Comes the sensor.
and it shuts it off before it's done.
Before it's on.
Sometimes just cleaning them or lightly sanding them just a little bit, not like scraping them, but just cleaning off all the oil or dirt will make this thing work properly.
Okay.
All right, let's go to the question. So how does the power resistor work? Well, the power resistor drops the voltage to the timer. On the Whirlpool, I don't know what the voltage is there. On the Whirlpool, instead of the timer motor getting 120 through here, it's about 98 volts. So that means from 120 to 98 is 22 volts.
Yeah, 22.
That means lower voltage. What's going to happen to the timer? It runs slow.
Slow.
So even when it's running, it doesn't run as fast as it does in a time cycle. And that is on purpose so that we extend the drying time to make sure the clothes are dry. But a lot of customers don't understand the cycles. How many of you guys actually bought something and sat down and read the instruction manual from cover to cover?
Not too many hours.
How many of you guys actually looked at an instruction manual? Probably never.
Not too many
Us guys, we know how everything works and we're gonna plug it in and we're gonna do it. Later, we're gonna go back to the instructions and figure out what we did wrong, but we don't read instructions. Well, customers don't either. So you have to just be nice and diplomatic and explain to them how it works so they understand what they can do to make it work properly. Now, those were just 3 specific questions. So I'm not gonna do any more, but every week now, I'm gonna start giving you guys different machines, different diagrams, maybe watch another video, and you guys are going to have to try to answer those questions. I want you to start thinking troubleshooting and problems in the machine. Now, on any of these 3 questions or anything on this diagram that you'd like me to answer before we end? You guys got any questions? No? Okay,
Yeah.
so then, thank you.
Yes, sir, thank you.